Hi, students. We are reviewing chapter number 2. So please turn to page 231. And the first problem we're looking at is problem 11, function given by a graph. So which of the following graphs are graphs of a function? Which of the function are one-to-one? So, well, let's have a quick review. So if a function is like y equals x squared, and then so if x is positive or minus 1, so if x is positive minus 1, and then y equals 1. So this is a function. This is a function because we can have multiple inputs and it has only one output. So this is a function. But if y squared equals x, when x equals 1, y could be positive or minus 1. This is not a function because there's one input and it generates multiple output, and we don't know which, and both of the output are correct. So so this is not a function because if you are given graph, the simplest way is just draw a horizontal line. If you draw a horizontal line, for example, here, it might be, this line might be x equals minus 1. So you are given only one input, one x. But if you notice, it has two intercepts with the contour. That means it has, for one x, it has multiple y. So this is not a function. This is not a function. And then, so for B, so for B, yes, it is. It only has at any point on the contour, it only has one intercept. So yes, it is a function. And for C, something, it is a function. But for D, for one x, maybe x equals minus 2, it has multiple intercepts. So this is not a function. Okay. And which functions are one-to-one? And so if you want to check one-to-one, you need to check because for a function, so we use horizontal, we use this vertical line to check a function. Oh, you need check function. Oh, my bad. Check. It's weird. Okay, if you want to check function, we use a horizontal line. Vertical line, my bad. Vertical line. And if you want to check if it is a function, and then we want to check if they are one-to-one, check. It's a little bit weird today, so please forgive me. Check one-to-one. Okay, finally, check one-to-one. We use the horizontal line. So if it is a function, for example, you look at C first, and I use a different color. So we use a horizontal line. And then, so on this contour, for every point on this contour, as long as we draw a horizontal line and we only find one intercept, that means for the same value of y, it only relates to one x. Okay, so this is a one-to-one function because for C, for anywhere of the horizontal line, it only has one corresponding x. So this is one-to-one function. And for function B, because if you draw at certain point, you draw a horizontal line, it has multiple intercept. That means for the same value of y, it generates multiple x. Okay, and it is not one-to-one. Okay, so this is B is only a function. Let me write. This is a function, and C is also a function, but only C is a one-to-one function. Okay, so this is quite basic. And then we look at the next problem, which is problem 13. Find the domain and range of the function. Okay, so domain is the scope of input. And then for the square root, for if x and y are both real number, we need what inside the square root positive, or we can say larger or equal to 0. So if we want to determine the domain, we look at x, and because it's inside the square root, we need x plus 3 greater or equal to 0, which means x larger, greater, or equal to minus 3. Raise others. X greater or equal to minus 3. And then we can represent it by bracket. We can say it is or equivalent minus 3 to infinity. Okay, so this is the domain. And then if you remember, if we use bracket, because when we use bracket, it means minus 3, the value of minus 3 is included. And then we look at the range. Because this is a square root. And if x and y, fx is a result of a square root. And if x and y are both real numbers, that means fx, or we can say y here, must be greater or equal to 0. And then, so this is fx. And we can write in bracket, that means this is bracket 0, infinity. Okay, so this is the range of this function. Okay, this is also quite basic. And the next problem we're looking at is problem 19. Fx equals, so there are three fractions adding together, and you need to your x to find the domain of this function. Because for fraction, and it requires that the denominator are not 0, because if the denominator is 0, and it is invalid. So we know that x can be any real number except 0. X cannot be 0. X cannot be minus 1. And x cannot be minus 2. Okay, so this is the answer, or we can write the domain is x for any real number x, but x cannot be 0, minus 1, minus 2. So this is the answer. This is the domain of X. All right, and let's look at the next problem. Find the domain of the function. Okay, and it has square root. So we need what inside the square root larger, greater, or equal to 0. So we have 4 minus x greater or equal to 0, and that means x is smaller or equal to 4. And then for the second square root, we need to have s squared minus 1 greater or equal to 0, which we have, this is x plus 1, x minus 1 greater or equal to 0. And for this problem, we could draw a line. This is 1, x plus 1, x minus 1, x plus 1. So we have 1 minus 1, and we plug in the numbers, and then so this is positive. If it's larger than 1, this is negative, and it's positive. So the answer will be because this is 1 and minus 1 are included, so x could be smaller or equal to minus 1. X could be larger or greater than 1. Okay, so if we use this, so we know the domain of this function needs to satisfy these two conditions. And so we have, combine these two, we have x is smaller or equal to minus 1, and x smaller or equal to 4, larger or equal to 1. So the union of so this is the answer, or we can write in bracket, which is minus infinity, minus 1, and minus 1 is included. So we use a bracket in union with 1, 4. Okay, so this is our answer. This is the domain of this function. Okay, this is the domain. Okay, so the rule is what if there's a square root, and then what inside the square root must be greater or equal to 0. So the next problem we're looking at is problem 29. Sketch a graph of the function. Use transformations of functions whenever possible. Personally, I don't know what transformation functions. Yeah, but the simplest way is to make a table and then plug in numbers. So if x equals 0, fx equals 1. If x equals 1, fx equals to 2. And then because it's square root of x, we want to make it an integer. So it will be easier for us to calculate. So square root of 4 is 2. 2 plus 1 is 3. And then we could make 9. The square root of 9 is 3. 3 plus 1 is 4. And then we put the 16. The square root of 16 is 4. 4 plus 1 is 5. And so we are able to draw it by drawing this point first. So the first point is 0, 1. 0, 1. This is 0, 1. And then the second point is 1, 2. The third is 4, 3. The fourth is 9, 4. And maybe 16, 5. So the graph is like this. And then if you, the domain, its domain must be x is greater or equal to 0 because x is what inside the square root. So which means this is the correct answer. Okay, so easy. And the next problem that we are looking at is also the same thing, graphing functions, but it has an this is called absolute value, right? So the same thing, we draw a table x f of x. So when x is 0, f x is 0, 1, minus 1, 2, minus 2, 3, minus 3. And also, if x is minus 1, it's still minus 1, minus 2, minus 2, minus 3, minus 3. So we are able to draw it on xy coordinates. So we have this line. This is a 0, 0, 1 minus 1 is 1, minus 1, 2 minus 2. So it's 1 minus 1. And then if x is minus 1, and it is fx is also minus 1. So this is the result. Okay. And so it is symmetric about y-axis. Okay, this is also a simple one. And the next problem we're looking at is problem 39. Determine whether the equation defines y as a function of x. So if we are given this, because we want to determine if y is a function of x, so we leave y on the left of the equation and then put x to the right. And then we try to solve y. And y is positive, negative 14 minus x. So for 1x, it may have multiple y. That means this is not a function. Okay, so for 1x, it will generate 2 y's. So this is not a function. Function can only allow multiple x and generate only 1 y. But we cannot have one input or 1x and generate multiple output. So this is y is not a function of x. Okay, and the next question we're looking at is problem 51. So for problem 51, it says net change and average rate of change. A function is given, and either numerically, graphically, or algebraically, find the net change and the average rate of change of functions between the indicated values. So in problem 51, you are given a table, and it asks you to find out the net change and the average rate of change of the function between x equals 4 and x equals 8. So, so net change, so this is 4, this is 8. So for the first problem, net change equals f of 8 minus f of 4, which is f of 8 is 8, f of 4 is 12, which is minus 4. And average change, so and then you are asked to calculate average change. Average change will be this f of 8 minus f of 4 and 8 minus 4, and which is minus 4 divided by 4 is minus 1. So average change also can be also defined by the slope. So the slope, well, if it is a linear function, okay, so slope. And if it is a linear function. But well, this function, by looking at the values of this table, this is not a linear function here. So I better do not mention it. Okay, so this is the average change between 8 and 4. Okay. The next problem we are looking at is problem 55. The same thing, we are looking at net change and average change. So, and same thing here, because it's very similar to previous one, so I just write it down. F of 4 minus f of 1 equals 16 minus 8 minus 1 minus 2, which is 8 minus 1 is 9. This is net change. For average change, is f of 4 minus f of 1, 4 minus 1, which is 9 over 3. This is 3. So the concepts are similar, net change and the average rate of change. So, which is simple here. Okay, and the next problem we are looking at is determining whether the given function is linear. And well, this is a linear function because if you draw this function on the xy coordinate, y here equals g of x, you'll be a line because when x equals 0, y is 3 over 5. When y equals 0, x equals minus 3. So this is minus 3. So you're able to draw a line here. If it's a line, if it can be represented by y equals mx plus b, this is the general form of a line equation, then this is a linear function. Okay, and for this, it has s squared here. It has 9s squared terms, so this is not a linear function. So this is also the definition of a linear function. Okay. And then the next problem we are looking at is problem 49. For problem 49, function f is given a, find the average rate of change of f between x equals 0 and equals 2, and the average rate of change of f between x equals 15 and x equals 50, were the two average rate of change that you found in part A the same? C, is the function linear? If so, what is its rate of change? Okay, so it asks you to calculate the rate of change between x equals 0 and 2, and between x equals 15 and 50. So we need to find out f0 is 0 minus 6 is minus 6, and f2 equals 1 over 2 times 2 minus 6 is minus 5. Okay, so the average rate of change, let's say m1, is f2 minus f of 0. 2 minus 0, right? This is the rate of change. Okay, will be -5 minus -6. This is 2 and equals 1/2. Okay, and for the rate of change between 15 and 50, we are using the same thing. So f of 15 equals 1/2 multiplied by 15 minus 6 equals 3/2. And f of 50 equals 1/2 multiplied by 50 minus 6 is 19. So let's define the rate of change between x equals 15 and 50 is f of 50 minus f15. 50 minus 15 is 19 minus 3/2, 35, which is 1 more 35 multiplied by 35 divided by 2, which is 1/2. And you can notice these two rate of change are the same. So, which means the rate of changes are the same for a linear function. Changes are the same for a linear function. So, and if it is a linear function, we can define this is slope. The slopes of a linear function at any segments are the same. So this is a simple problem, but I just want to tell this. So if it's a linear function and at any point its slope are the same. Okay. So for the next question, we are looking at problem 71. Suppose graph of f is given. Describe how graphs of the following functions can be obtained from the graph of f. So for a is easy. You just shift to the top by 8. Or we can say shift upward by 8. Okay. So for problem B, you can say, well, it's +8. So x star, suppose initially x start from 0, but if it's x +8, and then x starts from -8, which means the graph is shifted to the left by 8 units. So we know for problem B, it's shift f of x to the left by 8. Okay. And for problem C, y equals 1 plus 2 f of x. And then because fx is multiplied by 2, that means it is stretched along the y-axis by a factor of 2. So and then shift upward by 1. So you can say it's stretched vertically by a factor of 2. And then shift upward by 1. Okay. And then we look at problem D. Well, x minus 2 equals 0. So x must be 2. So x must be 2 to start from f of 0, right? So it is shift to the right by 2. And then since it's -2 here, so shift to right by 2 and shift downward by 2. Okay. And then we look at problem E. So the problem E, fx becomes f minus x, which is, but they have the same y. So we can think of this. So this is x, y for this. And then when x becomes minus x, it has the same y, which means it is symmetric about the y-axis. Okay, so for this figure, it is symmetric about y-axis. And problem F, since x becomes minus x and y there's a minus here, so it is symmetric about y-axis and also x-axis. Symmetric about a y-axis and then x-axis. ABOUT. Problem G. Well, this is just symmetric about x-axis because we flip y here, right? So just like this is x and y, and for y, and then minus y have the same x, just is symmetric about x-axis. Y and minus y will generate the same x. So it is symmetric about x-axis. And problem H. Y is the inverse function of fx because we have y equals fx here, and we have this is y equals f minus x. These two functions is the inverse functions of each other, and then for inverse function, we switch x and y, which means these two functions, they are symmetric about y equals x. So this is they are inverse function. So it is matching about y equals x. So this is the definition of an inverse function. Okay, so these definitions are important, and so please memorize them. And the next problem we're looking at is problem 73. Determine whether f is even, odd, or linear. So before we look at this problem, we need the definition of an even function is f minus x equals fx. This is the definition of the even function. For example, This is an even function. It is symmetric about the y-axis. And for odd function, we have f minus x equals minus f of x. So it is like x and y. Okay. It is how can I say, this is symmetric about so this is odd function. Okay. Symmetric about the origin. Okay. Symmetric about the origin. Symmetric about the origin. Yeah. Okay, so before we determine even and odd function, we need to know what is even function and what is an odd function. So we look at problem A. So problem A, so we make f minus x equals this is minus 2x5 to the power 5, and it's minus 3x squared plus 2. And then is it equal to f of x? No. Is it equal to f of, so f minus is not equals to f of x, because this is not the same, and it is not equal to minus f of x. So it's neither. Okay, and then if we look at problem C, and how about let's look at problem B. Problem B, f of minus x equals minus x to the power 3 plus x to the power 7. It equals minus f of x. Okay, then it is an odd function. And then we look at problem C. We have f minus x equals, then this is x squared, 1 plus x squared. This is the same as f of x. So this is an even function. And we look at problem D, f of minus 2 minus x equals 1 minus x plus 2. So it is not equal to f of x, and this is not equal to minus f of x. So this function is neither an even or an odd function. Okay, so these definitions are simple. So you need to know how to determine if this function is an even function or an odd function. Okay, the next problem we're looking at is problem 83. Problem 83 is combining functions. So if fx is x squared minus 3x plus 2, and g of x is 4 minus 3x, find the following functions. And we only talk about 2 problems here. The first is composition of f and g. The second is the composition of G and F. And this composition, they are not interchangeable. So composition of the result of composition of F and G is not equal to the composition of the result of composition of G and F. So we look at problem E first. So the composition of F and G. So we say F, the composition of F and G, X is you put G into F square minus 3 or minus 3x. So you put G into F, this is square plus 2, which means 16 minus 24x plus 9x squared minus 12. This is not square. Minus 12 plus minus 12. This is plus 9. What? Minus 12. Okay, this is 3x. Minus 12 plus 9x plus 2, which equals 9x squared minus 15x plus 6. This is the answer for problem E. So the composition of F and G is you put G as a variable of F. Okay, and for problem F, G, the composition of G and F. X is, then you assign Fx as a variable for G. So 4 minus 3, but right now Fx is a variable, which is x squared minus 3x plus 2. It's 4 minus 3x squared plus 9x minus 6 is minus 3x squared plus 9x minus 2. So which is the answer. Okay, so this is called the composition function. Okay, and for next problem, also a composition function is that you need to find out the composition of F and G and H. So which means you need to put h of x as a variable of g of x. So which means you need to put fx into here to replace x. And after you calculate fx and g of x, and then you need to put them into x to replace x in the f of x. So we can write this. We look at for g is 1 minus, but you need to replace x with 1 plus square root of x. Square root square, right? And then you need to replace x in f of x by g. So we have 1 minus this, the whole thing is the x in f of x. So this is f, the composition of f and g and h, x equals. Okay, so this is how we compose it, and then we try to look at these equations. This 1 minus, we multiply, but we expand this, so this is 1 plus 2 square root of x plus x, right? And then so we could have this 1 minus, this is 1 minus 1 minus 2 square root of x. Wait. square root of x minus x, 1 erase. So you have this is 1 plus 2 square root of x plus x, which equals 1 plus square root of x squared, and then which equals 1 plus square root of x, which is the answer. So we could have multiple functions. They are in composition. And for a composition function, it has the sequence matter. So you put, if it's layout like this, f and g and h, you use h to replace the variables in g. And then you got a new function and use this function to replace the variables in f. Okay, that's how we calculate this composition function. So any questions? If no questions, let's look at the next problem. One-to-one functions determine whether the function is one-to-one. And then, so for problem 89, apparently when you assign different value of x, it only generates one f of x. So yes, it is one-to-one function. For any x, so you can plug in numbers. For any x, it generates only one f of x. It has only one output. If you still have doubts, you could draw the graph of this by plugging in numbers, and then you can find it out. And then for problem 91, because it's x to the power 4, so we have if x minus 1 or positive 1, they all generate. So for x equals positive minus 1, y is 1. So you have two inputs, but it has one output. So this is a function, yes, but it's not one-to-one. You have multiple input, but only generate one output. So it is not one-to-one. Not a one-to-one function. Okay, should be an easy one. For next problem, we're looking at problem 95. Find the inverse of the function. So you may ask to find the inverse of this function, and to make it easier, we make fx equals y. The first thing is, if you want to find the inverse function for this function, we need to put x on the left of the equation. And then, so you have 3x equals y plus 2. And then x equals y plus 2 over 3. And then replace, this is the first step, and second step is switch x and y. So y equals x plus 2 over 3. And this is the inverse function of fx. And then how can we double check? So if we have f inverse function x, the answer will be x. Okay, so the inverse function is just undoes what f does. So for inverse function, what fx does. So for f of x, it converts x to a value. But if we put or in this case, we could say, but either way, so okay, we have f of f, yeah, and let me keep this f inverse function x, or we have f of x, and then we put it inside the inverse function, it also generates x. So they are the inverse function of each other, and so it undoes what f of x does. So for fx, it converts x to a value, and if you put this value into the inverse function, and it generates x, it undoes f of x does. So let's double check. So we have f of x, we put it f of inverse. So f of inverse is y equals 3, and we replace 3x minus 2 with the x in the inverse function minus 2. And apparently, wait, this is what? Oh, this is plus 2. Okay, so apparently this is 3x over 3, which is x. Okay, so it undoes what f of x does. So yes, this is an inverse function of f of x. Okay, so this is the definition of an inverse function. And we look at the next problem, find the inverse of the function. And same thing here, it's easier to replace fx by y. And then the first step is you want to put x on the left of the equation. So we could have this square root, and this is the third roots. The third roots of y equals x plus 1. So x equals the third roots of y minus 1. And then we replace the second step, switch x and y. So we have y equals the third roots of x minus 1. Okay, so this is the inverse function of f of x. Same rule here. Okay, and you can double check. It will have this. If you double check, you will always have x or f inverse f of x, and then this is f of this f inverse equal x. So it will satisfy these two properties. Okay, let's look at the next problem. So the next problem is problem 99. A graph of a function f is given. Does f have an inverse? If so, find f inverse 0 and f inverse 4. So for inverse function, okay, for inverse function, inverse functions, they are symmetric about y equals x, because you switch x and y, so it's symmetric about y equals x. So what is y equals x here? So y equals x here is this line. So which means use different color if we want to draw the symmetric function of f will be like this. It will be totally symmetric. So again, the graph, it will be totally symmetric. We'll go for here, here. Okay, and so we draw this is its inverse function. That means f inverse. So f inverse 0 is -1. No, f of inverse 0 is here. Let me use different color. Use black. F of inverse 0 is 1. So it is 1. And f inverse 4, 1, 2, 3, 4, which is here. So this is 3. Okay, so f inverse 4 is 3. And does f have an inverse? And yes, it has an inverse. So this is y equals x. Yes. Okay, so this is the property. These are the properties of an inverse function. Okay, let's look at the final problem of this chapter. Graphing inverse function. So sketch a graph of the function f of x equals x squared minus 4, and x is larger or equal to 0. Use part A to sketch the graph of f inverse. Find an equation for f inverse. So the first A, we need to sketch this function by plugging in numbers, right? So we have x. This is the simplest way to draw a graph. So x larger or equal to 0. So when x is 0, fx is -4. When fx equals 1, it's -3. When it's equal to 2, it's 0. When it's 3, it's 5. When it's 4, it is 10. So which is enough? We draw this figure of f of x. Is x and y. Okay, when x is 0, this is -4. When x equals 1 is -3, press me here. When x is 0, and when x is 2 is 0. When x is 3, it may be 5. Okay, when x 4, it may be 10. So you have this. Let me make some arrangements. Maybe here, here. Yeah, you have this. And use part A to stretch the graph of f inverse. So for f inverse, so suppose this is y equal to x, and then so it is symmetric. So this is metric about y equals x. So this is -4 here. So this is f inverse. Okay, symmetric about y equals x. So this is f. This is how to draw the inverse function graphically. And for problem C, this is B. Find the equation of f inverse. So if you want to find the equation, it's easy. You have 2 steps. First step is you put x. Suppose fx is y. X squared equals y plus 4. And x equals, wait, this is okay, x equals square root of y plus 4. You have Okay, and then, well, let me double check the answer. 101. 101 is here. Okay. And then switch X and Y. So Y equals square root of X plus 4. So this is the F inverse, the inverse function of F. And then you are able to, because X larger than, so it, well, supposedly it will have, because we take the square root of X, we need to have positive, and wait, what happened here? Okay, supposedly we will have positive and negative here, but since X is larger or equal to 0, then it's always positive. Okay, so that's why we only keep a positive when we take the square root of X. So X only has a positive value here. So, and then we switch X and Y, and we receive the inverse function of this F of X. So that's how we find out the inverse function graphically and mathematically. So this is so we finished the review of chapter 2.